Your factoring skills kick in, because notice that you can factor the numerator, the x squared minus 4, as x minus 2, x plus 2. Well, I have x minus 2 on the bottom. I can cancel that out, and this is what you do with them. You try to do something algebraic so that you can simplify them. And then you basically just repeat the plug and check process. You try to plug the number back in again, and hopefully you'll get a solution. And in this case, if I plug in x equals 2, I'm no longer dividing by 0. I'll get 2 plus 2, or 4. And that's the answer to my limit. So the limit of x approaches 2 of x squared minus 4 over x minus 2 is going to equal 4. And if you graph the function x squared minus 4 over x minus 2, it's going to look just like the graph y equals x plus 2, which is a straight line, except for it's going to be undefined at the value of 2, because that gives me 0 in the denominator. So I made a little graph here. Here is the graph of y equals x squared minus 4 over x minus 2. Notice at 2, it's undefined. Again, visually, if you look at this graph, it says if we take x coordinates closer and closer and closer to 2 from either side, notice that the y coordinates are closer and closer to 4. So that's the way to read a limit off from a graph. Basically think what's x getting close to, and then look at the graph and think what y coordinates am I getting close to, in this case 4. Notice it doesn't even matter that it's undefined at 2. That's perfectly acceptable when we do limits. For our first limit problem, we're going to look at the limit of x approaches 2 of x squared minus 4 over x minus 2. And again, the idea is we're putting in numbers close to 2, and we're trying to see what types of numbers we get out. Of course, you can always do this on a calculator, plugging 1.9, 1.99, 1.999, put each of those numbers into the formula, and see if the numbers you're getting out are getting close to something. But again, these can kind of give you deceiving results, because maybe if you plug in 1.999999, you get something much different. And in general, on a test or an exam, they're going to want to see something more algebraic anyway. So to get started, again, you always try to make it x equals and substitute it in and see what you get. So if I plug in x equals 2, notice I get 2 squared, which is 4, minus 4 over 2 minus 2. I'm getting this form 0 over 0, which means, hey, you're going to have to be a little more creative and figure something else out. Well, this is where your factoring skills kick in, because notice that you can factor the numerator, the x squared minus 4, as x minus 2, x plus 2. Well, I have x minus 2 on the bottom. I can cancel that out. And this is what you do with limits. You try to do something algebraic so that you can simplify them. And then you basically just repeat the plug and check process. You try to plug the number back in again, and hopefully you'll get a solution. And in this case, if I plug in x equals 2, I'm no longer dividing by 0. I'll get 2 plus 2, or 4. And that's the answer to my limit. It says the limit of x approaches 2 of x squared minus 4 over x minus 2 is going to equal 4. And if you graph the function x squared minus 4 over x minus 2, it's going to look just like the graph y equals x plus 2, which is a straight line, except for it's going to be undefined at the value of 2, because that gives me 0 in the denominator. So I made a little graph here. Here is the graph of y equals x squared minus 4 over x minus 2. Notice at 2, it's undefined. But again, visually, if you look at this graph, it says if we take x coordinates closer and closer and closer to 2 from either side, notice that the y coordinates are getting closer and closer to 4. So that's the way to read a limit off from the graph. Basically think what's x getting close to, and then look at the graph and think what y coordinate am I getting close to, in this case 4. Notice it doesn't even matter if it's undefined at 2. That's perfectly acceptable when we do limits. And in this limit example, again, we try to plug in h equals 0. Notice that we do plug in h equals 0, it's 4 squared, which is 16, minus 16, so again we'll get 0 on top. Clearly we're getting 0 on the bottom. So we have to do something algebraic to try to figure out what's going on here. Notice the only thing that I see right off the bat, at least, is this 4 plus h squared. So we can always expand that out and see if something cancels out. So again, remember this is 4 plus h times 4 plus h. So 16 plus 4h plus 4h, that'll give us plus 8h, plus h squared minus 16, all over h. Well, 16 will cancel out, and I'm left with h plus h in the numerator, but since they both have an h, I can factor an h out of there. Then I have h plus h left over, divided by h. And again, now I can cancel out my h's. And this h in the bottom is what's, certainly giving me some problems anyway, because I'm dividing by 0. So I'm left with the limit as h approaches 0 of 8 plus h. And again, we go back to our old trick of plugging and chugging. If you plug in h equals 0, we're left with